I'm very excited to have Guy, the founder and
Gee,
CEO of Latitude, which is a bare metal infrastructure provider for developers. I'm very keen to go a bit behind the scenes and learn more about what is powering the fastest blockchain around, Solana. Welcome, Guy.
thanks a lot, Louis. Thanks for having me.
Yeah, it's a real pleasure. We went behind the scenes with Lane quite some time ago, and it was actually one of the most listened to episodes of all time for the Cove. So I'm really keen to dive behind the scenes with you. But before we sort of learn more about what you guys are working on, I'd love to just get a little bit around yourself, where you're coming from, and how you got into the game of bare metal infrastructure.
Perfect. Yeah. So my name is Guilherme. I am based in São Paulo, Brazil, where I born and live. I have been building in the internet since '97. I built several business since my 13-year-old, from search engines to e-commerce platforms. Many of these business succeeded, some other failed. And in 2001, I entered in the hosting industry. Started the business at 16. It was a business that provided email and website hosting services for small business, particularly in Brazil. The servers was not physically hosted in Brazil. They were in the US, but the customers were from Brazil. It was a time that distributed computing and edge platforms was not too relevant, so it was okay to have computing globally dispersed from the end user. In the crypto, I bought Bitcoin in 2012, which I paper handed, but
We all did.
got really excited about the tech behind it, and how much powerful Bitcoin and Ethereum really is. When I met smart contracts, I got fascinated about it. Played a lot in DeFi on multiple chains. I think that the first DeFi that I played with was one in Binance, Pancake Swap. So it was really
Pancake Swap. Yep. I remember
Pancake
that.
Swap. Yeah. And I'm currently CEO at Latitude.sh, which is a global bare metal computing platform.
And okay, so the thing is, I guess that in technical manners, like we could go super deep. Well, I mean, I probably couldn't go as deep as you, but to bring the listeners along for a ride, can you explain like what is a bare metal provider? What are you guys doing in a day to day, and like what's the main way that you guys touch point with crypto?
Cool. Latitude.sh is a bare metal platform that enables companies and developers of high throughput applications of any kind to get access to computing, to distributed computing across the globe. Latitude currently is used across Web 2 and Web 3 by many software as a service companies, streaming, gaming, and blockchain nodes. So particularly bare metal is used by any application that demands a lot of performance, that pushes a lot of bandwidth to the internet, and that requires a low latency. This is what makes bare metal more compelling than using any kind of virtualized environments. Our platform. Go ahead.
Yeah, so I'm just curious, when you say virtualized platforms, people may be familiar with something like Azure or AWS. Is that what you're talking about when you say virtualized platform?
Yes, correct. Any
Okay.
any of the hyperscalers, the big three, AWS, Azure, GCP, they are built on top of virtualized environments. They have a hypervisor running in the physical machine where they allocate many tenants to
Hmm.
this physical server. And this is usually pretty good for general use cases across the web. Web applications in general works pretty well in that type of environment. But for high performance, high throughput applications like Solana, which we will talk in a few, and any other kind of really perform application that demands really low latency that cannot be impacted from other tenants, the bare metal is more compelling. There's one thing called a noisy neighbor in virtualized environments where a tenant could use as a CPU and take performance from the other tenant. And
Mm.
on top of that, the CPUs that the hyperscalers use, they have a lot of cores, like 128 cores. The reason for that is the hyperscalers must optimize to allocate many users to the
Hmm.
computing, right? When you have a CPU with 128 cores, the clock speed is low. You cannot have a huge amount of cores at a fast speed, and this trade off is not usually good for high throughput applications.
Got you. I love trying my hand at really janky metaphors, and so I want to try one here and see how it lands for you. So, would it be fair to say that your hyperscaler like AWS is a bit like a if serving data is like going from A to B in location, it's a bit like you have a school bus that can accommodate many different people and can maybe take more people or less people, and then you have like a Ferrari or a Porsche which is more performant but only fits one person, and they have kind of different use cases, right? Like if you have a city that requires a lot of people to move from one place to another, you want a large transport system that can accommodate this varying numbers. If you have just one person that needs to get somewhere really fast, then you would have say a sports car. Is that like a relatively, for the non-technical person, is that like a relatively accurate metaphor?
Yes, I think that's perfect. Probably that would not be perfect on the cost perspective,
Uh-huh.
right? A Ferrari
Because they can get
costs.
quite expensive, can't they, the hyperscalers? Like
Yes,
if you're scaling
exactly.
quickly. Right. Got
If
you.
you are using a lot of resources on hyperscalers, particularly bandwidth, egress traffic is where when you push data from the computer to the internet, you and if it scales a lot for the application that is running, it gets quite expensive on hyperscalers. And usually bare metal providers are quite more affordable on the egress.
Okay. And now if we bring things back to kind of crypto, the crypto side, there is an angle where the hyperscalers are seen in a bit of a negative light because they're like a bit of a centralizing force. You'll see graphs of Ethereum having a large number of nodes running on AWS, for example, whereas the benefit of a bare metal provider is that you have many different providers who are decentralized and there's much more variety. We saw a few months ago with, I think it was Hetzner, who booted off a lot of validators in one go. And that was actually like, I think, a decentralizing event in a sense because a lot of nodes then moved to bare metal providers, I believe. So this is another benefit of the bare metal provider over the hyperscaler. Let's Let's go in a bit more and see, because you mentioned that you also support other high performance use cases. I saw on the website, like there is League of Legends, for example, the developer from League of Legends. But focusing in on crypto here, like at what point did Latitude become interested in crypto? Was it from the beginning? And also, I see that you guys have a lot of inputs in the Solana space. Is there some special elements of Solana that you find particularly interesting?
Yes, absolutely. So Solana is a high throughput blockchain, right? That demands high performance machine. Solana produces blocks every 400 milliseconds, and that's why the requirement for high performance machine is quite higher than traditional blockchains where you produce a block every couple minutes. So you demand on Solana high performance computing, low latency network, and that's where Latitude could bring a compelling offer for to Solana community and other high throughput blockchains. That was in our core by providing these high performance computing across Web 2. So early last year, an RPC provider came to us and requested some machines that we didn't have, but and that's how we got deep on understanding what were the requirements. And we have built three types of machines that are purpose built for Solana and other high throughput blockchains. So we could understand by talking with multiple teams and developers what specifically we should have on a validator, on a consensus validator, on RPC node, on an RPC node that needs to provide fast API retrieval responses and and indexing the whole Solana. So I think that's why how many of the Solana teams are choosing Latitude, because we could understand, we could go deep and understand the requirements, and not only that, but we made it easier for developers to spin up these nodes. So they are not most of the node operators, they are not really DevOps experienced. They are so we worked with the community on building some Ansible playbooks that they could play with and spin up a node in 5 to 10 minutes, depending on its the use case that they needed.
Okay, I want to double click on a few points you raised there. So the first one is you mentioned that Solana and other high throughput blockchains. I had I think it was Frank from Genesis Go on like a year ago, and he said something like that being a validator for Solana prepares you to be a validator for basically any other blockchain because it is like the most demanding. I'm curious just to get your take there very briefly, like which other chains are sort of the most close to, in terms of being demanding to Solana.
The similar chains, actually not similar. They all are really different. But in terms of computing requirements, there is Sui, Aptos, and Say that I think
Mm-hmm.
will be the most similar than Solana. They have pretty much different number of nodes, and most specifically validators running and securing the network. Like Say has 50 validators, Sui has 104, Aptos
Mm-hmm.
will be about 150, and on Solana we have like 2,000 validators. It's but they all share the same computing computing requirements. They need
Mm-hmm.
lot of fast cores, a lot of memory, and NVMe drives to produce these
Okay.
blocks pretty fast. Yeah.
Got you. Second topic is in terms of the specs. No, actually, before we go into the specs, I'm curious. Like you mentioned that we have 2,000 validated nodes on Solana, but then we also hear the word RPC thrown around. Could you just briefly tease apart like the difference between a validator node and an RPC node, just for the sort of non-technical person?
Sure. Yeah. A validator node is part of the consensus. They agree on what is being voted in each block, what is submitted to each block. To run a validator node, you need you need stake, and that's it. You actually pay for one sol a day to be able to vote. So you build your validator, your consensus validator. You need to pay one sol a day to be part of the consensus. But on top of that, you need to bring stake to be relevant to the network. So pretty much what a validator is doing is part of the consensus. And the RPC, while they share the same, actually similar specs in terms of hardware, they are not part of the consensus. You don't need stake in an RPC node. You're basically serving API requests, reading and writing to the blockchain. So any dApp that is running on Solana or any other blockchain is using our RPC node to connect to the blockchain, read transactions, submit transactions, and all that. So the RPC, you read from an RPC node, and you write, and the RPC node submit the transaction for to the validator. That's pretty much that.
Okay, so the RPC nodes could go down, and it wouldn't cause like a loss of consensus. It's purely kind of operating as a read write mechanism. And then you also mentioned the indexing side. I don't think we have time to go too deep in this side, but I believe that this is a whole other kettle of fish. In terms of indexing such a fast blockchain. Is this something that you guys are working on as well? And maybe if you could briefly just speak about the challenges there.
Yeah, we actually provide the foundational infrastructure for many teams to build on top. So we are basically providing the bare metal instances for many of the RPC providers, making it building APIs on top to enabling developers on its apps. Indexing, the reason why you need. So let's go back a bit on specs. On the validator side, you need a fast CPU, like 3 gigahertz CPU, and 256 gigabyte of RAM is more than enough. But on the RPC side, you would need 500 gigabytes to 1 terabyte. The
Of
reason
RAM.
for that, of RAM, yeah.
Gee.
The reason for that, yeah, the reason for that is to index the programs from Solana to RAM. In order to serve the requests when you query the blockchain, you need to store these programs in RAM, right? And Solana has I don't know how many programs, but it's a ton, and you have to store them all on RAM. And yeah, that's the challenge. You need pretty beefy machines to run an RPC node.
Because I remember the last time I was making a gaming PC, I think it was maybe 32 gigabytes of RAM or something. So you're talking about, significant increases there. And in terms of indexing all this throughput, what does that look like?
So what do you mean by that, Lee?
Like, so in terms of specs, or like, how does that process
Oh,
work in terms of indexing?
in terms of hardware requirements
Yeah,
for these cases, yeah,
yeah.
yeah. The validator you need uh, basically most of the companies and teams are running AMD CPUs for any type of use cases on Solana, right? And particularly any other blockchains as well. It seems that Intel is not working good enough. So AMD seems to be the the CPU chosen by most companies, and that's another reason why the hyperscalers are not performing well because they mostly use Intel based CPUs, which is better for virtualization. But they are using these AMD's 24 cores, 3 gigahertz of speed for any type of use cases, because for any type of node that you're running, you have to keep up with the blockchain, right? You need to be on tip of the network and not falling behind. Otherwise, you'd have outdated data, right? You would either serve outdated data from your RPC, or uh, you perform pretty well on the consensus side. In terms of indexing, the validator don't need to index. That's why you need pretty lower RAM size. There are
Mm,
many validators that are still running on 128 gig of RAM using Ryzen desktop CPUs, and they are live and keeping up with the network, and
wow.
it's fine. But when you go to the RPC side, where you need to serve requests and index the programs, you have you have two options. You either go with a 500 gig machine, which you would be able to serve RPC requests, but it will be limited to a couple program IDs. So let's say you just need MageGated or any other programs. That's fine. You can use 500 gig machine. But let's say you were an RPC provider and you want to serve any of the programs that Solana provides for your customers, you need at least 1 terabyte of RAM, and it's growing.
Wow. That's wild. One question there, because you've mentioned CPUs and RAM quite a bit. Some people may be aware that with the rise of AI, there's been a huge crunch in terms of graphics cards, and NVIDIA's stock has been going up a lot. Is there any like requirements on the graphics side, or is it purely like a CPU slash RAM game?
Uh, no, not at all. You only need CPU for any type of use case on Solana and any other blockchains. You the only requirement for GPUs right now in the crypto world would be for ZK, zero
Mm-hmm.
knowledge. These the technology that allows you to provide proofs without providing the information itself. So there are a couple companies that are building this technology, and it seems that this technology is also doable on CPU, but it's pretty slow due to the algorithms that runs there, and and that's where I think the GPU infrastructure will be a requirement for these ZK technologies.
It seems like gamers really can't catch a break because, shortly after Ethereum goes to proof of stake and the graphics cards are affordable again, AI takes off. And so that's interesting. I guess you guys are not working in that specifically, but it is interesting to hear that the zero knowledge, for example, rollups will be quite GPU intensive, which is that's something to keep an eye on. So speaking about more about decentralization, you mentioned a little bit at the beginning around the hyperscalers. There's a lot of talk about Solana being not sufficiently decentralized because of the high performance requirements. Um, could you share a few different ways that you think about decentralization? For example, I don't know, geographical decentralization, or ASN, I believe Tolly refers to sometimes. What are some of the angles or the vectors of decentralization that you're thinking about?
Yeah, you mentioned ASNs, right? That totally means ASN. He means by the provider. Every ASN stands for autonomous system. So any carrier or any provider that run its own infrastructure, they run an autonomous system, and that's important because um, sometimes you have, like, you were let's say you have nodes in 5 different providers, but just one provider runs the autonomous system and the other 4, they are resellers of this one provider. You are not decentralizing at all, right? You are running behind the same infrastructure. So I think that many people talk about Nakamoto coefficient, which is a good metric that measures how many parties should collude to take over the blockchain. But there are other metrics which I think it's important as well, like data center distribution and provider distribution. So a blockchain must be in as many data centers as possible and operated by as many different providers as possible. A data center is different than a provider because you can have multiple providers hosting in the same data center, right? So you have, uh, I'll give you an example. There are some locations that we overlap with AWS, right? Or Azure. So we are a colo client from let's say Equinix, but AWS is as well. In that sense, you are sacrificing decentralization if you're running one node with each party. So that's my point. And it seems that Solana is currently running on 200 different data centers, which is pretty impressive, pretty good, because many of the other blockchains, they operate, they actually run 100 validators, right? Less than data centers that Solana is currently distributed. Node count, go ahead.
One question there. So the one point I see raised sometimes on Twitter is that although Solana has 2,000 nodes, maybe the accusation is that actually many of them are run by the same people. Is there ways to actually tell that, or is it really difficult?
I don't think that's particularly true. There is some stake concentration from whales that they are running in the hyperscalers and they don't care. Like I think AWS right now, they have 10% of the stake concentration for Solana, which is pretty, it's big, right? But and I think that should be dispersed and distributed more than it is right now.
And how do you think about liquid staking options? We've been seeing Marinade making some really nice improvements with the directed stake recently. Any thoughts on liquid staking?
Yeah, we actually we run a validator under the brand of Latitude on Solana and other high-throughput blockchains, where I think our service has a compelling offer, and we have integrated with these liquid staking pools. It is really cool, right? You can use you can stake, still earn the rewards from that validator, and use the the token across DeFi. Um, yeah, it's pretty interesting, and I wish people used it more. I think they it's uh, right now most people only do direct staking to their preferred validators, and they don't use marinate options as much. But it's I think it's pretty positive for the ecosystem because they are distributing a stake across many of the node operators based on geo and stake concentration, performance, all of these metrics. And we get a lot of stake from Marinate right now. I think that the concept is amazing. It actually abstracts from the delegator the everything about staking, right? He don't need to care about how the validator is performing and and everything else. It's pretty good.
Yeah, definitely can encourage everyone to liquid stake your soul, especially with the new improvements that have been coming from Marinade and from some other players. It's a great time to start liquid staking. I think up until recently there was not significant benefit, and you were adding some additional smart contract risk. But now with the directed stake, we're seeing some validators offering up to a significant increase on the standard staking returns, as well as you can then use the liquid staked token for other things in DeFi. I do hope that we'll see more usage of liquid stake tokens in DeFi across the space to give them more utility. But already, I think it's a bit of a no-brainer. So I'd love to see more people picking that up. Moving on to like the economics of running, as you said, you guys are running a validator. Moving on to the economics of running a validator, I actually originally came across Latitude on Twitter because you had an offer. From my memory, it was something like $350 a month, and you can spin up a Solana validator. Could you speak a bit about like the process and the cost of spinning up a validator, and then a little bit about, like you were mentioning before, there's a cost, a daily cost of stake. So like, what is the break even point where people can start to expect to actually make money on their validator? So could you run us through the economics?
Yeah, sure. To run a validator, you basically need the right hardware and pay the voting fee to keep the validator running, which is right now one sol a day, right? Basically, this you need the computing, which Latitude provides for 350 a month, and paying one sol a month. I have used it for this conversation. I have used Cogent Crypto calculator to understand the break even. So for anyone that is interested, there's a Cogent Crypto provides a calculator that is pretty easy to use. So the cost to run a validator would be 11K a year, including hardware and one sol per day as voting costs. So to break even, you need 110K staked sol if you were running a 5% commission validator.
Mm-hmm.
If you are self-staking, you need more. But if you get delegation, 110K would be enough to break even the validator.
And when you said self-staking, say, I imagine I'm running a validator and I liquid stake and then direct the stake towards myself. Is that still self-staking, or what would that count as?
That's a good question. I think if you use the public key, I might be wrong on that, but if you use the public key associated with the validator itself, it will be considered self stake. But if you were like using another wallet, there's no way it will know that you were self staking, right? And I honestly need to learn more about this, but I don't think there's a way to know that that's self stake or not. And
Got you.
probably it's pretty easy to get away with that.
Got you. And in terms of, you said it's 11K to set up the validator. So there's an annual cost of 11K. What would, just like ballpark, say once you get 200,000 or 300,000, like what kind of returns can you be expecting?
Uh, yeah. So if you have 110K stake at Sol, you were paying the costs. Right now, we are running, our validator has around 400K stake.
Hmm.
That comes direct from 260 different delegators. Some are the liquid staking pools, and some other are just people staking directly to us. I think our validator is doing about 3K a month after paying these annual costs for hardware and voting costs.
Okay, got you. Um, and for the budding node runner who hears 3K a month and they're interested in getting started, what what do you need to have in terms of skills or background to be able to run a validator successfully?
I would say a basic DevOps Linux experience. You need to know how to log into SSH, which is a terminal, right, and run commands. So, but um, this is not rocket science as well. And with the chat GPT, it's pretty easy to learn how to log into SSH and run anything. But, and yeah, I would say like really basic DevOps experience. And as I mentioned in the beginning of our conversation, there are some Ansible playbooks that community built to set up a node in few minutes for these different use cases that we covered from validator to RPC. This resource is under Manistake website. The URL is latitude.sh.manistake.com. So, and there you have the step by step on how setting up these different nodes. It's pretty straightforward.
Okay, nice. If we zoom out a little bit from the tech, the running the validators, you've been in the Solana ecosystem for a while now. I'm curious to get your take on where you see potential and like what excites you in this space currently.
Um, Outside the crypto or both?
No, inside the Solana space, whether it be DeFi or NFTs, etc.
Um, yeah, good question. I find Solana fascinating from a user experience point of view, like using other blockchains. Depending on the use case, you feel how fast Solana is interacting with the different apps, and that's why Solana got the adoption that it has. Not been the first mover, which had a big advantage to Ethereum, for example, and um, it seems early, and I'm particularly excited about the getting more DeFi volume on Solana, and 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 Fire Dancer would be a really cool to see when it comes to life as well. They are going to the core of the coding, and they are building this client on C. They made um, a long term bet with Jump, and it seems that it would be really interesting to see how faster we could get to Solana, and as we get more transactions per second, uh, if we can get way more transactions per second that Solana has right now, I'm sure there will be many interesting use cases we'll be about to see and developers doing for that. And I think there's no other blockchain um, optimizing for that for a massive amount of TPS. That'll be really cool.
Yeah, the TPS, and not just the TPS, but also, what I'm also very excited for, and I've seen Tolly posting about, is the latency. Bringing the latency down. He has that thing where he wants to have consensus at the speed of light. I mean, I find it really exciting and promising that the laser focus is on performance and speed, and this is going to be exciting to see how far we can push it, how many gigabytes of RAM we need at some point.
Yeah,
Yeah.
latency will bring more decentralization as well if we can improve latency between the nodes, right? Yeah, most nodes are currently not only for Solana but for many of the blockchains. They're most concentrated in US and EU. If we can get better latency, and you will have consensus validators setting up their nodes in South America, for example, and not skipping blocks. That will help a lot with decentralization.
I remember also at Breakpoint, Tolly mentioned something about like multiple leaders at the same time, and then you could have like geographically located leaders. So, if you were executing a transaction in Africa, you could have like a leader in Africa and I think that would also help to reduce latency and then spread out geographical diversity in terms of where the nodes are located. But I can't speak to the technical possibilities there. I know it was on his roadmap or his plans. We'll see if they manage to figure that out. So let's chat about a prediction for the future. We're speaking on a day where the SEC is going after a lot of different players, and things seem a little bit shaky. But I guess now more than ever, decentralization comes up, right? Like we have an environment which is very hostile in the US, but crypto lives on, crypto moves on, and it's partially because of that decentralization. We don't have all the nodes in the US, we don't have all the teams in the US. So I'm curious to get your take on, like, can we achieve meaningful adoption while maintaining meaningful decentralization? Do you believe?
I believe so. I truly believe. I think, like I mentioned earlier, while the data centers and operators on Solana should further diversify, uh, um, Solana already demonstrated that it's possible to have over 2,000 nodes across 200 different data centers and achieve a Nakamoto coefficient of 33 and process a lot of transactions. We had some meaningful mints going on recently on Solana that during the software optimizations that were made the last year, we didn't have any kind of bottleneck or outage. So, and I think, and especially with the Fire Dancer, which will improve things further, with the improvements on hardware, which is the bet for the core bet of Solana, right? There's already the new CPUs coming out with a massive amount of computing, like multiplying by a factor of 2 times what everyone is using today. I am positive that we'll have no issues there, and decentralization will get better and better, and performance better and better, and high throughput blockchains will prove itself over time.
So Moore's law is not dead just yet?
Yeah.
Okay, so I think this has been a very instructive episode for people who are interested in running a node or interested in learning more about how things run behind the scenes. Um, for folks who want to like maybe dive deeper, like this has been a jump off point for them, and now they want to explore it further. Is there some specific resources you could recommend for people to jump into this topic?
Yes, there is this little website that we put together. Manistake is the validator that is operating under the Latitude brand. And if anyone is interested, going to latitudesh.manistake.com. There's a good resource for setting up the nodes. And if anyone is interested on DMing me on Twitter or Discord, I'm happy to uh, help as well and take them to the appropriate resources.
Perfect. And is there like a specific community or Telegram or Discord where people can ask questions that you could recommend?
The best one is on Solana. There's two channels that's there. One focuses on RPC operators. I think it's RPC server operators or something like that, and the other one is validator support. There's another one as well from Overclock. There's a Discord Overclock. We can perhaps put the link
Yeah,
in the
for sure.
description. And to get support specifically for these Ansible playbooks, the best resource will be the Overclock Discord on AutoClock RPC channel. That'll be the best.
Okay, perfect. Yeah, I mean, that's super specific. So, yeah, I hope this has been a thought provoking episode for folks, especially if you have a bit more of an inclination towards learning more about validators, learning more about the tech that's actually running this super high performance blockchain. Thank you so much, Guy, for coming on and sharing the knowledge and sharing the expertise. Um, it's it's an exciting time to see, especially with Firedancer coming, to see how far we can push the technology, how far we can push the hardware. But yeah, really great to have teams like you guys building in the space and making it so much more straightforward and easy to get involved.
Thanks a lot again for having me, Louis.
My pleasure.